In today's lesson on pages 349 and 350, we'll be covering Lesson 2 of Unit 11, Radian Angle Measurement. Just as distance can be measured in inches, feet, miles, centimeters, etc., rotations about a point can also be measured in different ways. Measuring one complete rotation as 360 degrees is one way. Another common unit of angle measurement that is an alternative to degrees is called the radian. You first saw this unit of angle measure in geometry. The definition of a radian: the radian angle theta, so this radian angle theta, created by a rotation about a point A using a radius r passing through an arc length of S, is defined as, so this is the arc length S. Theta is equal to S over R, so the angle measure is equal to the arc length over the radius, which is equivalent to, if we just multiply both sides by the radius, the arc length S is equal to theta times R. So the angle, the radian angle measure is equal to the arc length divided by the radius. In turn, the arc length is equal to the angle measure times the radius. You want to memorize this. It's not given to you, and I'm not sure which one you learned last year in geometry, if it was this version or its equivalent. I usually use S equals theta R. Consider a full rotation around any point in a counterclockwise position direction. What is the arc length S? So in other words, I'm rotating counterclockwise. What is the arc length of this rotation? Well, this is one complete circle. So it would have to be the circumference of the circle. Writing out the word circle, I'm just using the symbol, a circle with a dot in the middle. And the circumference is 2 pi r. So capital C for circumference equals 2 pi r. Based on the definition of above and on your answer to part A, how many radians are there in one full rotation? So our arc length S equals theta times r. Our arc length is 2 pi r equals theta times r. So divide by r both sides, and theta equals 2 pi. Theta. In other words, 2 pi radians is equivalent to 360 degrees. Use the formula above, S equals theta R, to answer each of the following. Determine the number of radians. So we want to determine the number of radians. This is theta, that the minute hand of a clock passes through if it has a length of 5 inches and its tip travels a total distance of 13 inches. Okay, so the minute hand of the clock, the length of that is the radius. And the distance the tip travels is the length of the arc. So that's S. So we have S is 13, R is 5. We want to find theta. Using our formula, S equals theta R, 13 equals theta times 5, divide both sides by 5, and theta equals 13/5, or 2.6 radians. And it's not necessary to write the word radians. B, if a pendulum swings through an angle of 0.55 radians, okay, so this is our theta value. What distance does its tip travel if it has a length of 8 feet? The 8 feet is the radius and the distance that the tip travels is S. R is 8, theta is 5.5, we want to find S. So S equals theta times R, 5.5 times 8 is equal to 4.4. And we have the same units as our radius, so 4.4 feet. Radians are used in higher level math and physics. It's important to be able to convert between the angular system of degrees and that of radians. Consider 1/2 of a full rotation. What is the angle of rotation in both degrees and radians? So 1/2 of a full rotation. So half of a full rotation would be, that's a straight angle, that's 180 degrees. And we know that one full rotation is equal to 360 degrees, which is equivalent to 2 pi radians. So 180 degrees would be half of 2 pi, in which case pi. So 180 degrees is equal to pi radians. Using the two equivalent angles of rotation in A, that 180 degrees is equal to pi radians, convert a 30-degree angle into an equivalent angle in radians. So if we have our 180 degrees equals pi radians, if we take 180 and divide by 6, do the same to our pi radians, we have 30 degrees is equal to pi over 6 radians. Now there's a formula on the reference sheet. So on the green reference sheet, we have 1 radian is equal to 180 divided by pi degrees, and 1 degrees is equal to pi over 180 radians. So the change from degree to radian, we take the degree measure and we multiply by pi over 180. Convert each of the following common angles in degrees into radians. Express your answers in terms of pi. So 90 degrees, we want to get rid of degrees and have radians, so we multiply by pi over 180. Our degrees would divide out, and we will be left with just radian measure. You can do 90 divided by 180 on the calculator. I am simply going to reduce. I know that 90 goes into 90 once and 90 into 180 twice. So this would be equivalent to pi over 2 radians. If theta is 120 degrees and we want to convert to radian measure, we take our 120 degrees and multiply by pi over 180 degrees. Again, the degrees would divide out. The degrees. The 120 and 180, I know 60 divides into 120 twice and into 180 3 times. So my answer would be 2 pi over 3 radians. Again, or you can take and simply take your calculator and take 120 divided by 180. Don't give me the decimal, math frac that. That's 2/3, all right? And just leave the pi in the numerator, so 2 pi over 3. 225 degrees to convert to radians, we'll multiply by pi over 180. 225 divided by 180. Math frac that, again, do not want the decimal, so 5 pi over 4. (316 degrees). To convert to radians, we will multiply by pi over 180. And I know 45 goes into each of these. 7 and 4, I believe. Let's see, 315 divided by 180. Yeah, 7 pi over 4. A 100 degrees, convert to radians. (5 pi over 9). And 198 degrees. Times it by pi over 180. Math frac that. 11 pi over 10. Now the other way to change from radian to degree measure, which is multiplying by the reciprocal of what we used above. We want to get rid of our radian measure, so our pi radians is in the denominator, so we'll be left with degrees in our numerator. Convert each of the following common radian angles into degrees. 5 pi over 6 radians. We will multiply, we want degrees, so degrees needs to be in our numerator. We'll multiply by 180 over pi. Our pi's divide out, and you can simply do 5 times 180 divided by 6, or 6 times 180. In my case, I think it's easier for me to just say, oh, 6 goes into 180 30 times. So we have 5 times 30 is 150 degrees. 3 pi over 2. Convert to degree measure. We multiply by 180 degrees over pi. Pi's divide out. 2 goes into 180 90 times. 3 times 90 is 270. 270 degrees. Don't forget the degree symbol here. 3 pi over 4 radians. Multiply by 180 over pi. I'll use the calculator this time. So I'm taking 3 times 180 and then dividing by 4. Oops. I wanted to do that all in one step, but so 135 degrees. Pi over 3, times it by 180 over pi. Pi's divide out, 3 goes into 180 60 times, 60 degrees. 3 pi over 4, times by 180 over pi. (315 degrees). And 5 pi over 18 times by 180 over pi. 18 goes into 180 10 times, 50 degrees. We should also feel comfortable with the fact that radians do not always have to be in terms of pi, although they often are. Convert each of the following radian angles, which aren't in terms of pi, into degrees. Round answers to the nearest degree. So this is a radian measure. To convert it to degrees, we multiply by 180 degrees over pi. So that's 1. So now we actually use the pi key on our calculator. And where is pi? It's here. So second, and I call this the caret key or exponent key. So 1 times 180 divided by pi. Oops, sorry about that. There it is. That's approximately 57 degrees. So 1 radian is approximately 57 degrees. 5.8 radians times by 180 over pi. 5.8 times 180 divided by pi. Not a pi. 332 degrees. 4.2 radians. Approximately 241 degrees. And negative 2.5 that's approximately negative 143 degrees. And our last exercise, an angle drawn in standard position whose radian measure is 2 radians would terminate in which of the following quadrants? All right, well in this case, we are more familiar with degree measure. So if we take our 2 radians and convert it to degree measure, that's approximately 115 degrees. At a 115 degree angle, it's between 90 and 180, right? So that would terminate in quadrant 2. Remember our quadrants from yesterday? Start in the upper right and go counterclockwise. Thank you for your attention today.